Welcome students. So under calculus, application of single integral, we can also call the definite integral for single integrals. For better understanding, I have selected a problem so that you can able to work out in step-by-step mechanism manner. First thing is that read the problem very clearly. So under calculus, application of single integral or definite integral. This is a problem in the calculus. Compute the length of the arc of the curve y is equal to 2x square. Y is equal to 2x square from x equal to 0 to x equal to 3 using definite integral or single integral. How to work out such problems? Already we discussed the formula for this, the previous video. First you should write down what is given to you. What is given to you? Given that, right? We can write point wise how many bits we are going to frame here from the information. So the length of the arc we have to compute. So we can take this one as let L, always L, you take L. L is the arc length of which curve? Of the curve that is going to be y is equal to 2x square. 2x square running from x equal to 0 to x equal to 3. From x equal to 0 to x equal to 3. Is only one information given to you. Our task is that next one, only one information is available in the problem. Task means what we have to find here. Compute L using definite integral or single integral. These two are same in your problem what it is given to you. Next, sketch the arc L. So you have to give a rough sketch about this graph. So I am taking here a small sketch, x-axis, y-axis, origin. The graph is a parabola. It is a parabola. Y equal to 2x square, y power 1, that becomes the axis. X power 2, don't bother about the constant. X power 2 is there. So it have two branches, one on right side, one on left side. Because x range is from x equal to 0 to x equal to 3, only first quadrant portion you need to show. So the graph will be starting from origin, this branch. This is your y is equal to 2x square. The other branch I am not showing, it will be outside, this side. Symmetrically, this side in quadrant 2, that is not required. There is a graph, y is equal to 2x square is a parabola. Now, what are the starting point and ending points here? X equal to 0 means here, this you can write as 0, 0. This is your x value. And other value is somewhere here you can take, it is 3, 0. 3, 0. This value x is also x. But in notation we can write this value as small a, this value as small b, because in the formula integration is from small a to small b. So this is the description. So x equal to, this is small a, we have taken in our formula starting value to ending value x equal to 3, this b value. To show that the coordinates where they are going to meet x-axis and y-axis, drop perpendicular on x-axis, we get 3, 0. Here 0, 18. How you got 18? x equal to 3, substitute here. 2 into 3 square, 2 into 9, 8, y value will be 18. So our first point is origin O comma O, 0 comma 0, and ending point is P 3 comma 18. So this portion length we have to find out. Once sketch is over, once sketch is done, then you need to work out these things. Compute rate, compute, you are heading compute. Under that first one, we have to find out derivative of this one, dy of x. So how to find dy of x? Dy of x is equal to, it is first derivative dy dx of y of x, that is equal to dy dx of y value, this one, it is 2x square, 2x square. So derivative is very simple, it is 4x. This is your derivative of y of x, first derivative. Second thing, we need to find out dy of x, its square value. Under compute heading, all these things you need to find out. So just we have to square. If you work out like this, no question of committing mistakes. 4x squared, that is equal to 16x square. So let us continue the third computation, dl, small change in length L. This is given by 1 plus derivative of y of x squared whole power 1 by 2. This already seen in that first video, dl part, change in length in x direction. So this portion I copied, 16x square, and the last stage is that finding the length of the arc, capital L. How to get length of the arc? L is given by adding the small bits from x equal to a to x equal to b, integrating these bits, this tiny bit from x equal to a to x equal to b. So a is equal to 0, b equal to 3 from the information of the problem. This as it is I dumped. So to evaluate such integrals, take care that the coefficient of x power 2 must be 1. To get 1 here, remove this 16 outside along with the power 1 by 2. The same thing I did here. 16 power half will be taken out. Inside it becomes 1 by 16 plus it is removed. We get only x square. Of course, same power 1 by 2. Square root of 16 is 4 as it is. And here a square plus x square form. Whenever you find this type of binomial, a square plus x square term is there, if this is appearing in any integrand, then you must substitute x is equal to a tan theta. A tan theta we can substitute using this logic. Here a is 1 by 4 tan theta. Substitution. Then we have to change the variable of integration dx. So 1 by 4 as it is, derivative of tan theta is equal to secant square theta. By using chain rule, we get d theta, dx in terms of d theta. This is done. This we are not. This we have to simplify further. Before that, I altered the limits. X limits, upper limit 3, lower limit is 0. To get theta limits, what is the upper limit? Take this x equal to 3, substitute in that supposition what you have taken in the beginning. If you put 3 here, tan theta becomes 12. So theta is equal to arc tan 12, or simply we can write tan inverse of 12. Substituting 0 here, we get tan theta equal to 0, theta is equal, lower limit is equal to arc tan of 0 is equal to 0. These are the new limits of integration. So this is the thing. We got 1 by 4 times secant cube theta d theta, limits from 0 to tan inverse 12. So just I substituted that limits, the integrand. Here I have taken 1 by 16 power half common. Here we get 1 plus tan square power half as it is. Square root of 1 by 16 is 1 by 4. Here also 1 by 4. So 2 1 by 4s are there. We can remove that. 4, 1 by 4, 1 by 4. This part is secant square theta power half secant square theta d theta. 2 and 1 by 2 will get cancelled there. It is 1 by 4. This is the ultimate integral we need to compute. It is because 3 is there. If it is 1, directly we can give the formula. If it is more than 1, 2, 3, 4 like that, we have to apply this relation formula. Integration of secant to the power of n theta d theta is given by secant theta power n minus 2 into tan theta by n minus 1 plus ratio n minus 2 by n minus 1 into I stands for integral. In stands for integration of this one, n minus 2. Reduce the power by 2 for n more than 2. That we have applied here. So 1 by 4 as it is. Here n is equal to 3. So we get 3 minus 2 is 1. Secant theta tan theta by 2. Integral is over. So 0 to tan inverse 12 plus n minus 2 by n minus 1, 1 by 2. N minus 2 means we have to integrate. 3 minus 2 is 1. So secant theta power 1 we need to get. This I retrace 1 by 2, here 1 by 2, remove outside, it becomes 1 by 8. Secant theta into tan theta, integrations from limits from 0 to tan inverse 12. And integral of secant theta is natural log secant theta plus tan theta, limits 0 to tan inverse 12. Now we need to plug in the limits and evaluate the value. How it is to be done? You can use directly calculator, or you can use inverse trigonometric rules to get the values of tan theta into secant theta at those values. So I would like to explain how to compute the integral. So first, in that integral final stage, I have taken the first part, secant theta into tan theta, limits from 0 to tan inverse 12. How to compute this? We have to plug in the upper limit and lower limit values. What you get here, secant, here theta is there, tan inverse 12 into tan, again theta is there, tan inverse 12. It is your upper limit value computation, minus same secant theta is 0 into tan 0. This is very simple. Secant 0 is equal to 1, tan 0 equal to 0. This complete contribution will be equal to 0. How to compute such values? Whatever inside part inverse functions are there, that you name it as some k. That is equal to some k. Apply tan on both sides, we get tan k is equal to 12 by 1. We have to use the definition of the tan theta, opposite by adjacent. You take a small triangle, here angle is k, I have taken here. Opposite side 12, adjacent side is 1. Hypotenuse will be square root of 1 square plus 12 square, that is equal to root 145. Here I will show this value is equal to square root of 145. From this, if you substitute k here, it becomes secant k. So secant k definition, hypotenuse by adjacent side. So root 145 by 1, root 145. Same logic we are going to apply here also. Therefore, secant of this value is equal to secant k, that is equal to 145. And second term, tan into tan inverse of 12. This already we supposed it as k, tan k, but tan k is equal to 12. So this complete value will be equal to 12 times root 145. Now the value of this limit, upper limit value is 12 into root 145. This value is 0. This contribution is 0 minus 0. So 12 into 145. One more term is there in that integral. Natural log secant theta plus tan theta 0 to tan inverse 12. Same methodology. First substitute the upper bound or upper limit secant tan inverse 12 plus tan inverse 12 minus natural log, plug in 0, secant 0 plus tan 0. So continuing the result to find the length of the arc. So mainly the problem depends on the integral evaluation. So you have to be very careful while computing the integrals. That plays a vital role here to get the accurate answer. So this is the final stage. So L is equal to 1 by 8 outside. So just I plug in the values what we computed. Log 1 is 0. So this is the final result of the length of the arc. You can use calculator to find out the value. So we can compute the numerical value using your calculator also. First what I did, because root 145 and natural log they are irrational numbers, that's why the symbol is changed. Approximately 1 by 8 as it is. This value we have computed up to 3 dp, 3 decimal places, 144.499 plus this value I computed. Square root of 145 is 12.042 plus 12. Later these two on adding we get 24.042. Then finding this value using natural logarithm we got 3.180. Then summing up these two we are going to get 147.679, and taking the division we are going to get approximately 18.460. So without using the manual method, directly you can use KCO brand FX991 ES or ES plus. So this you can see the value exactly matching over there. Directly substituting the limits of the original integral, you are going to get the same value what I computed. Hope this video is very clear to you. The thing is that the student should be able to work out the integral in systematic manner. That only plays a vital role. So if the integration method is correct, then we are going to land upon correct answer. It is just the arc length from x equal to 0 to 3, what the complete portion length is approximately 18.460 units. So do subscribe our channel, and in this playlist you are going to get applications of line integrals or single integrals. Then we are going to start double integrals, then and triple integrals, which plays a vital role in engineering mathematics. Do share, like and subscribe. If any doubts are there in working procedure, you can post your comments clearly in comment section. I give prompt and clear reply to your queries. God bless you. All the best.